Ba-bam, ba-bam-ba-bam-bam-bam, ba-ba-ba-bam. How's it going on this wonderful Friday? Have you got that Friday feeling? No, everyone should just shut up now. Cool. Cool. Right, so as I mentioned in the Discord, this is probably going to be a little bit shorter than the previous lesson, but we shall see. We're going to recap on the stuff that we did last stream on interpreters, and we're going to have a look at compilers and the differences therein. I have the wonderfully attractive woman from that movie that I saw ages ago on the screen there. She is a human interpreter, but we're not interested in that right now. We are interested in computer interpreters, code interpreters, if you will. Just quick discussion amongst yourselves. And can someone tell me what an interpreter is, what the point of an interpreter is? Maybe you could give me some advantages, disadvantages of using interpreters. What do they do? What is the point of an interpreter in terms of like... and you might even be able to give me some examples of programming languages that use interpreters. Yes, we have done this already, Tommy. This is called a recap. Okay, so we're recapping. Review. We're going over it again just to make sure that you can remember it all. Yeah? Ollie says, translates, reads and executes lines of code into machine code. Yeah, so it's taking the code that we write, and it is translating it into code that the computer understands. Because computers do not understand Python, computers do not understand C++, computers don't even understand assembly language. All they understand is ones and zeros. So what the interpreter does, it goes through your code line by line. Here's a question for you, though. This is something that I didn't mention last lesson, but it's something that I have sort of explained over and over in the past. So you've got your program. Imagine you've got a program and it's filled with a whole bunch of functions and loops and all sorts of other things, right? The interpreter, does it start at the top and just go all the way down and convert everything from the top to the bottom and then finish and run the program? Or does it do something different? What's your thoughts on that? So he goes from the top to the bottom. He goes line by line, stops and finds an error. Okay. I tell you what. Bear with. Let me just pull up an actual Python program here. And I mean, you are correct. It will go through the program until it reaches a point that it where it can't run, and then it will crash, right? But let me just give you an example here. New Python file. Oh, actually, I know what I'm going to do. Let's have a look at this one. Control L. And I need to actually display this on the screen, so just bear with me one moment. Yes, okay. Is that gonna work? No, it's not displaying anything. Oh wait, I know why. Okay, for some reason my Python thing isn't actually displaying, although it appears to be. Can I move that up? There we go. Right, so I've got a Python program here. So what you guys effectively are saying is that when the interpreter goes through, it will start here at line 1. It will translate that, and it will keep on going. It will translate that, and then it will translate that, and then it will translate that, and then it will translate that, then it will translate that, and then finally it will translate that. Is that what you guys are saying? Don't worry about what this program actually does. I mean, you can see there's a function there. George says no. Does anyone agree with George? I don't mean in a general sense. I mean just on this point here. George says it does not do what I said. That ain't how it be working. So George claims that we are not just translating that, and then translating that, and then translating that, and then translating that. He says that's not what's going on. Does anyone disagree or agree or aren't sure? Feel free to say you're not sure. Just sound off down there in the chat. Let me see your feels. Alex says maybe. Gemma says she agrees. Anyone else? I disagree with George on numerous occasions about the curvature of the Earth and legitimacy of the moon landings. If only, Tommy, if only you would focus on the lesson. Yeah. Ollie isn't sure. Isn't Python changed at runtime? Right, okay, so here is what actually happens. And this is not just Python, right? This is a variety of interpreted languages. When I said the interpreter goes through line by line, that's true. But it's not like when you read a book and you start at the top and you read all the way down and then you reach the bottom. Because remember, the code is not executed in that order either, right? And so what Python actually does is it only translates the lines when it needs to translate them. Okay, so in this example program, which is an example program that I wrote to prove that Python doesn't actually support dynamic scoping, we hit this first line, x equals 10, brilliant, boom. We can understand that. The interpreter translates that into whatever machine code is necessary for the machine that it's running on. And then we go down here, there's nothing there, we go down there, there's nothing there. This line here is a function definition. Now the interpreter does translate this, and basically what it does is it says, okay, there's a function and it's called f. Okay, there's a function called f, and so let's just put that to one side. We know that that function exists. We'll come back there when we need it. It doesn't actually execute the function. Just like when you're writing the program, the function isn't run until you call the function. And so the interpreter translates this line, does what it needs to do, and then it skips the rest of the function. So it ignores that. Down here, down here, down here. Okay, we've got another function definition here. It's going to translate that, and it's going to do what it does in order to allocate memory to store whatever is going to be in that function. But at the same time, it's just going to say, okay, we'll come back to that function as and when we need it. Okay, so it then skips over that. Boom, boom, boom. Good. So now we've actually haven't translated these lines yet because we haven't need to execute them. Okay, so now we're skipping down here, and then we get this line here, print G. And so what the interpreter does is it says, okay, cool, I need to translate this print line, but before I can translate this print line, I need to work out what it is I'm actually going to print. And the thing that I'm going to print is whatever comes out of this G function. So then the interpreter jumps back up to the function, okay, and then it starts translating this stuff. X equals 20, return f. So then it skips to the f function, it returns x, that goes back down here. Do you see how this is going? So it's not a case of you write the code and it runs from top to bottom, executing and translating everything it goes. It will translate things in the order that the code would normally be executed. Does that make sense to everyone? I find it fairly ironic that when I asked Tommy to concentrate, the people who were not actually concentrating were arguing about who concentrated the best, while other people actually paid attention to what was going on. That's kind of, isn't that interesting, guys? Yeah. Notice I'm not using the generic term guys here to refer to both male and female. I'm saying guys because it's always the guys that never pay attention. It always seems to be the girls who actually focus on their studies. Interesting that, isn't it? And then people say, why do girls end up with better grades? Must be a coincidence. Weird that, isn't it? And yet, women always seem to get lower pay in their jobs. It's almost as if there's some sort of gender pay gap. Anyway, I'm getting off topic, so let's just get back to the topic at hand, right? Where's my pie chart? Let's just get rid of that. Boom. We're back on. Oh man, what is her name? I can't remember her name. Help me out here, guys. Nicole Kidman. There we go. That was her. Nicole Kidman. So we're back to Nicole Kidman, but we don't need to be because we've just gone over that. Anyone? Does anyone? What was I going to say? Can anyone give me some advantages or disadvantages of using interpreters to run our code? Yes, you are quite right, George. You are not allowed to answer this question. However, as Amy and crew are in here, they are allowed because I haven't actually gone over this for a long time, and I want to test their knowledge. Slower than compiled languages. Yes, it is. It is slower, but it is easier to locate errors. Okay. Anything else? And feel free to go into some explanation over this stuff, like why is it easier to spot errors? Why is it running slower than compiled languages? I mean, I appreciate the fact that I haven't gone over compiled languages with many of you, so you probably don't even know what that means. So so we've got so far we've got an advantage. We've got, if it's called twice, does it translate twice? It depends on the language, depends on the interpreter. Usually no, because what it will do is it will translate and it will store that translated function in memory, or that translated code in memory. However, that's not always the case, and also there's a limited amount of some languages will have a limited amount of storage to keep those. It's kind of like a web browser cache, I guess. That's a really flimsy analogy, but yeah. Yes, the interpreter needs to be installed on the machine that you're running. So, I mean, there is an advantage there in the sense that if you are writing a language which runs on an interpreter, and that interpreter has versions for various different operating systems, different hardware, you can write the code once and it will run on all of those different machines. But you need to have that interpreter installed on the machine. And you can't always be sure that your end users are going to have that. So there you go. Right, what else have we got here? It's vulnerable to code injection. Yes. Can someone explain what code injection is? While you're doing that, I can go through that. You can change the data type on the fly. Yes, we've got dynamic typing. That's good. So yeah, I mean, when you say easier to code, sort of. I mean, it's it can be easier, but at the same time, having strict data type definitions for different variables can actually make it easier to understand what's going on with your code sometimes, because you always know certain variables are going to be a certain data type. So yeah, that's a bit of a trade-off. I wouldn't necessarily say it's easier to code. It can be in certain situations, but being able to switch between data types can be a very useful thing. When you enter code into some text form produced by the program into which you put your code to be naughty. Yes, that is code injection. I mean, you can either edit the code and stick your own stuff in there. I mean, the fact that usually with interpreted languages you can see the code, so that you can see exactly how it works, so you're able to like reach in and change things. You know, that's there's a thing. Has anyone confused? Anyone can fiddle with it, meaning they can make the code do some bad things. Yes, that's true. And even if they don't have access to the code, but they have an understanding of what's going on, you can do some fairly nefarious things. We are going to have a look at writing files, storing text files, and storing serialized object data in files using Pickle. We're not going to do that this lesson, but you can do some nasty things just by loading text files and stuff. You can do code execution if you know what's going on. It's worth noting it is still possible to do code injection attacks on compiled languages, but it's a lot more difficult. What else did people mention? The compiler will tell you there's an error somewhere when compiling. Yeah, so we're getting into this is sort of double-edged sword territory. The interpreter will run the program up to a point and then it will stop, so you can see which parts of your program are not working, and then like when it breaks you can say, oh cool, that's the bit that I need to fix. Whereas with the compiler, as we're going to find out shortly, if one part of your program doesn't work, the whole thing fails to compile. And a lot of people see that as a bad thing, because they're like, oh, I can't even run part of my program. But sometimes it's a bad thing to have part of your program run and not the not the rest. I mean, for example, what if you had something that starts up a nuclear reactor and then shuts down the nuclear reactor, and your code works to start it up and then crashes and it doesn't shut down the reactor? You know, there's a potential thing. Did my stream just cut out then, or what's going on? I don't know. Cool! Platform independence. That's a very, very useful thing. Now, there are some compiled languages which are platform independent. Java is the one that springs to mind. Not to be confused with JavaScript. I don't know if I've mentioned this to you guys, but you've probably heard people using the term Java and JavaScript, and often they will lump them together, but they're actually two totally different languages. Java is a compiled language. JavaScript is an interpreted language, and they are designed to do different things, and their syntax is different as well. Boing. Yeah. Okay. So in terms of the thing cutting out, don't know what that was all about. I'll try and yeah, I don't know. Maybe they're on to me because I have been employing K-pop stans to flood racist hashtags with fan cam nonsense. Anyway. It seems to me that you guys have got a pretty good understanding of what interpreters are. Anyone got any examples of interpreted languages? I've already mentioned a couple already. Just throw them out there. Let me know. I've got this tiger balm and it smells so good, and it's supposed to... Oh man. I'm going to put it to one side because otherwise I'm going to be opening it and smelling it all the time. JavaScript, Lua, yes. Bash. Bash is another example of an interpreted language. Yeah, Visual Basic. Let's not talk about that though. Python is the obvious one. There's a little bug crawling around here. Cool. Okay. So, just out of interest, has anyone programmed in any of those languages other than Python at all? I mean, I know some of you have tinkered with JavaScript. Anyone ever looked at Lua or Visual Basic? I'm not going to. By the way, I don't consider Scratch to be a programming language. So I'm not going to. It's a visual programming framework, I guess you could say, but it's not really a programming language. Small bit of C#. Now, C# is not an interpreted language. That's a compiled language, which is what we're about to look at. Please stop posting fork bombs in the chat. Thank you very much. I can change gravity in Gary's mod. Yeah, so Gary does. I've not played around with Gary's mod. Does Gary's mod use Lua? So C++ is not an interpreted language. But yeah, I mean, I would say if you've got a reasonable grasp of Python, it's fairly easy to get the hang of any interpreted language because they tend to behave in a similar way. Lua tends to have more brackets. JavaScript has more squiggly brackets. Python has more colons, but you know. All I'm saying is you might want to have a look into that stuff. If you understand Python and you want to sort of broaden your horizons, that you might want to do that. Anyway, so I'm guessing as well we've got no problems with interpreted languages. No one's got any questions. Just before I move on, one of my advantages down here. Let's turn that laser pointer thing on. More free. What do I mean by more free? Does anyone remember? When I said more free, what did I mean by that? People can edit it. That's part of the answer. Why is that potentially a good thing? Why does that mean you have more freedom? It relates to open source. Freedom to change the program. And why might you want to change that program? Why do you want to change the program? No one knows. No one's got any suggestions why you might want to change a program? I mean, optimization, sure. If you've got a program and you think, oh man, this ain't working very well, and you wade in and you say, actually, if I change that, it might be better. Yeah, it might not be user-friendly, or rather, it might not be user-friendly for you specifically as a user, so you might want to fix it so that it does what you want to do in the way that you want to do it. Okay, rather than being handed a program and said, there it is, get on and use it, being handed a program and being said, there it is, do what you want with it, it means that you can edit it and you can add your own features in there. If there's something that isn't working as well as you might want it to work, you can make your own changes, you can add features, you can customize those features. Generally, it's a good thing. Now, we are going to cover open source software later on, right? But just being able to see the code, that's not specifically what open source means, right? Open source means you can see the source code and you can make changes. But if you redistribute those that source code, you should also allow other people to make changes on top of your changes as well. Okay. So just being able to see the source code doesn't necessarily mean that something is open source. Okay. If you can see the source code and you're able to make those changes and then redistribute it and allow other people to make additional changes, that there would be open source. Cool! Right, do you want to know about compiled languages then? Seeing as Alex has mentioned C++ and Java, what is the name for those languages? A compiler. I'm not going to get you to go on the internet and search for the definition of compile, but here's your tier 2 vocab. The verb compile does not just refer to computer systems. If you compile something, compile is a verb. Obviously, I've stolen this off the internet. The verb means to produce a list or book by assembling information collected from other sources. As an example, the local authority must compile a list of names and addresses of taxpayers. Okay, you might compile a list of interesting videos on YouTube that help with one specific subject. Okay, I mean, you've heard the term compilation before, right? That's where this comes from. When you watch a YouTube playlist like important videos, that is a compilation of a variety of different videos that fit the theme. Okay, important videos, for instance. Does that make sense? What the word compile means, just in a general non-computer science related sense? The Bible is compiled by lots of stoned prophets. Yes, okay. Cool. Yes, it makes sense. It makes sense. Mung together. Yeah. I mean, I think the important thing here is that you're taking information from a variety of different sources and you're pulling them together into one thing, which is not the same as all of the other stuff just mashed together, but you're pulling certain bits and assembling it into something which does a specific job for a different purpose to the original bits, if that makes sense. Okay, so hope you've got your notes open, because here we go. We're gonna note the F up here. Program compilers. They do the same thing as interpreters, but they do it in a different way. Okay, so this is what a program compiler does. It converts your source code to machine code, just like an interpreter. Okay, because your computer needs to have machine code in order to run. But instead of doing it line by line and running it as it goes along, it converts the entire program at once, right? So it checks the whole program for errors. If there's a single error anywhere in that program, it's going to say, nope, ain't working. Okay? And in most compiled languages, you'll find that that single error, time and time again, will be a missing semicolon on the end of the line. Okay? So, I mean, obviously, there's a hell of a lot more to it than just this. And at A level, we look at exactly what goes on. So there's error checking, and there's two aspects to compilation called Lexing and Parsing. Now, at GCSE, you don't need to know about Lexing and Parsing. So here's the quick rundown. It's basically looking at a line of code and breaking it up into tokens that can be understood and then converted to different instructions. When I say print hello world, well, that's actually doing a whole bunch of different stuff to get the words hello world output on the screen. You need to move certain binary information into certain places in memory. You need to look up certain characters in the ASCII character chart. You need to send that information into your screen buffer and stuff like that, right? There's a whole bunch of stuff that goes on. In the same way, here's one way of looking at it, right? I am assuming, and this might be a wild assumption, but I'm assuming you can all ride a bike. Is that a reasonable assumption? Yes. Okay. Well, Alex says he can ride a bike, so I assume he is a representative sample of everyone watching. Okay. So you don't think about how do I ride this bike? Yeah. Someone says, "Oi, get on your bike and ride down the road." You say, "Cool, okay." I pick up my bike, I get on it, and off I go. Right? You are riding the bike. But if you stop to sort of break apart what you're actually doing, well, what is riding a bike? You're sitting on the bike, you're holding onto the handlebars, right, and you're pedaling. Okay, you pedal. I'm speaking sense, right? Stop me if at any point I am not speaking sense, right? So you're sitting on the bike, holding onto the handlebars, and you're pedaling. But what does pedaling mean? Okay, you can break that down as well. You put your feet on this weird crank and you turn them around in a circular motion. Okay, and what happens is that turns a gear which has a chain attached to it, which pulls a second gear which is attached to your rear wheel to turn the wheel to propel you along. Okay? And the whole time as well, you're actually balancing and you're using physics, gyro stabilization to balance, and you don't even think about that. That's a background process that happens. That's not something that you do. That's something that an external source does for you, i.e. the universe. Okay, well, the gravitational forces acting on the planet. Okay, the point that I'm making here is ride your bike might be the command that you type in, right? However, that command gets broken down into lots and lots of other commands that can be understood by the universe. So pedaling, it gets broken down into pedaling, sitting on, holding onto the handlebars, but even pedaling gets broken down. Okay? And then, of course, there's all of these external forces and stuff like that. And if there's any problem with any of those things that you're doing, you ain't going anywhere, right? You won't even be able to ride your bike. Okay, let's say you sit on your bike and there's no chain on the pedal. There's an error. Okay, your bike ain't going anywhere. Yeah, you start pedaling and you break your leg. There's an error. The bike's not going anywhere. I'm really stretching this analogy here, but I'm hoping that you can see it. And there was also a reason why I brought physics into the whole equation here, and that's because down here you will notice this last bullet point, which I did not mention. Once compiled and libraries linked, you have an executable file. Okay, now what I mean by that is as follows. Yeah, and this is more detail really than you need at GCSE, but it's interesting and it helps you understand it a bit more. When you compile a program, it doesn't just spit out an executable. Okay, it compiles your program into what's called object code, which is a bunch of ones and zeros that the computer understands. Now, when you write your program, you will import additional libraries. I mean, even in Python you do that, right? Import random, import turtle. These are extra bits which you haven't specifically written, right? But they exist and they can be used in your program. And so in Python, what happens is the interpreter jumps to those code listings and it runs those things from the code listing. In a compiled program, what happens is you will have your your object code here. Yeah, you will have the library object code here. FYI, for those of you using Windows, libraries are often referred to as dynamic link libraries or DLL files, and you've probably seen a few of those in your time. But what happens is that external functionality which you have borrowed and drawn on in your program is then linked together. Okay, it's not like the whole thing, the whole program that is being compiled is formed from all of those different things and mashed together into one massive file, but it's linked together so that it can draw on those different parts. Now, let's just go back to that definition of compilation here. Produce a list or book by assembling information collected from other sources. Well, that's what's going on there when you're linking those files together. Okay, so at GCSE level, all you really need to understand is you write the code, you compile the code, and then you get some machine code which becomes an executable file. Okay? But if we're doing this properly, what's actually happening is you get that your compiler takes the code that you've written, it converts it to machine code, and then it gets any other things that you have linked in, and it links them into your file, and then and only then do you get the executable file. Okay. Anyone that has played video games on Windows will have probably installed DirectX at some point, or will have seen when they've run a game, Steam will say installing VC++, something or other. Okay, that's what that's doing, is installing those libraries that go together to make the games run. And that, to go back to my riding a bike analogy, that is why I brought physics into the equation, because you have no control over that. The laws of physics are just a thing that exists and flat earthers deny. But when you are riding your bike, it still comes together. Without that physics, you wouldn't be able to ride your bike. Okay? I appreciate that was quite a lot of explanation all in one go there, right? But remember, you don't have to take notes on literally everything that I just said. That was me explaining what's going on with these bullet points here. So, before I move on, I'm taking a little bit longer with this than maybe I originally intended. That's because you're familiar with interpreted languages and you're not familiar with compiled languages. But does that, for the most part, make sense? Yes, yes. Alec and James seem on the level. Has anyone? I assume everyone else has probably gone to sleep from that. No. They're still here. That's cool. Right. Good. So that's basically. I mean, in a nutshell, compilers do it on the fly. Interpreters do it on the fly. Compilers do it all in one go. You kind of get the same result. But there are some associated advantages and disadvantages, and they're not. I mean, it's not exactly the opposite of the advantages and disadvantages from interpreted languages. Okay. Some examples of compiled languages. You may have heard of C. You may have heard of C++, which was C++ is one of the most popular compiled languages, although it is being displaced by C# and, well, Java in certain contexts as well. So C, C++, C#, Java, Fortran, which is a very old programming language, and COBOL, which was one of the very first programming languages. I've given you a clue with that picture that's on the screen there, and also just use your brain thoughts. Think about what the differences are between interpreted languages and compiled languages. Maybe refer back to your notes as to what the advantages and disadvantages of interpreted languages are. Have a quick discussion and see if you can come up with a list of advantages and disadvantages of compiled languages. While you do that, I'm going to go and make myself a cup of coffee, which I'm going to drink from this mug. Yeah, that's right. Go Power Rangers. And when I get back... No, Fortran has nothing to do with 4chan. When I get back, you guys can tell me, or you will already have some stuff in there. So I'll be a couple of minutes. See if you can come up with some advantages and disadvantages of compiled languages, and then, and only then, we'll move on to the next slide. Okay, and here is some music. I don't know how good this music's going to be. Alien Invasion, this one's called. Cool. Right, how we doing? Let's have a look. Go flower range. Do you know what? If I was a florist, I would totally call my shop Flower Ranges. It wasn't actually coffee grinder time. I've run out of coffee beans, so I have some ground espresso stuff. I've made a small espresso, and also I muted the mic. So you should worry about yourself if you can't go an hour without coffee. Thanks for the advice. One day your metabolism will slow down as well, and we'll see how well you do. But no, you are right. But the thing is, it's only a small cup, right? Death 2002. When someone's teacher is doing constant live streams, whereas my teacher isn't interacting with us at all. Well, feel free to carry on watching. Right, advantages. Faster than interpreted languages. Yes, way faster than interpreted languages. Requires the interpreter to be installed. Right, so here's the thing. Because compiled languages don't use an interpreter, they create standalone programs, right? You can create a program in a compiled language which is a single file, and all someone needs to run that program is that one file. Okay, you can do that. So there you go. What's this? Stream should be unlisted. No, I'll keep my streams public. Anyone can tune in and learn stuff. That's why I do what I do. Once it's compiled, it runs quick. Yeah, now that's the thing. Once it's compiled, as you could probably tell from this hilarious comic, which I stole from xkcd.com, sometimes it takes a long time to compile code. A long time. And when I say a long time, I mean it can take hours. Hours and hours, depending on how big the code is and what sort of system you are using. And obviously, if you've been compiling for hours and then there's an error in your program, well, okay, fix that error, start compiling again. Okay, so that can be a it can be a downside. I helped you through your GCSEs a year ago. How did you do? Hope you did all right. At least make the whipped coffee thing on TikTok. Don't know what that means. Do people can't bootleg your code? Yeah, I mean, when you distribute once you've compiled your code, you have an executable file. You send that executable file on. People can't see the code. People can't edit the code. Sort of. You can take that executable and you can decompile it, but you won't see the code as it was originally written. Variables will be replaced with random letters, and it becomes very difficult to see what's going on. Generally speaking, it's not it's not an easy job to see the code in a compiled program. Okay, so generally speaking, you will not be able to see that code, which could be a good thing, but it could also be a bad thing. We'll discuss that in just a second. Before the first compilation, it is slow. After that, it's well, you only have to compile it once. Okay, so understand here, once you've compiled the program, you have that program, and it doesn't have to be compiled again. So you're sort of correct here in that it takes a long time to compile, but the running of the program is fast. Okay, so it won't run the program at all until it's been compiled, but then once it's been compiled, the running of the code will be faster than an equivalent interpreted language. Okay. That's got to be insanely strong coffee. Why are you guys hating on me for coffee, man? You know? look, I didn't get much sleep last night. This is my excuse, right? I've been having a lot of trouble sleeping because there's a lot of bad stuff going on in the world right now, and it's really bothering me. And so I am fighting to stay awake because I went to bed at 2 in the morning, didn't actually get to sleep until about 4 in the morning, and then I got up at 6 in the morning and I couldn't get back to sleep. So maybe you'll forgive me if I still stream but just chug a bit of coffee rather than sort of like saying, oh, I'm not feeling up to it today, guys. Okay, is that all right? Is that okay? Just, I'm not having a go at you. I'm just maybe explaining the situation a little bit. If you edit the program, can the compiler only recompile the changes to save time? Certain compilers can, yes. There's another thing as well that compilers do, which I haven't mentioned, which is code optimization, which is something you look at in at A level. Okay. Can you just recompile the bits that were changed? Yes, you can, but the thing is, your compiler needs to be able to spot which bits were changed. And sometimes as well, just because you change one bit in the code, that doesn't mean it's going to change just one bit in the machine code because of the way things are laid out. There's a lot of memory management and stuff that goes into code optimization, which means that sometimes it's not feasible to just recompile that one bit. However, what we usually do is we'll have a number of different files which are compiled into a number of different objects, which are then linked together into the final executable, right? And so, using that methodology, if there's an error in one of your files, or if there's something you need to change in just one of those files, you would only have to recompile that one file, and then everything would still be linked together. Does that make sense? Why are you guys still talking about coffee, man? Can you get interpreters for things like Java? No, Java is a compiled language, therefore it has to be compiled. There are things called JIT compilers, just-in-time compilers, but they're generally used for debugging stuff. You can do a little bit of your own research on that. Cool. So here we go. Here's my list. My pre-compiled list of advantages and disadvantages for compiled languages. They're super fast, and they produce standalone executables, which means here's your one file that will run your program. You don't need anything else, okay? Which is good. Some compiled languages can allow more direct control over the hardware, and what I mean there is, in theory, you can directly access things like video memory and store things directly into video memory, whereas with an interpreter you wouldn't be able to do that, because what you are doing is you're saying to the interpreter, hey, yo, can you do this for me? And then the interpreter is saying to the operating system, I wouldn't mind doing this if that's all right. And then the operating system is saying to the hardware, cool, we got this done. Yeah. So you're sort of going round the houses there. I mean, that's not the case for all compiled languages. It depends what operating system they're running on. It depends what it is that you're trying to do. But generally speaking, you've got more chance of directly accessing hardware with compiled languages than you do with interpreted languages. And that is another reason why they're fast. I mean, the primary reason why compiled languages are fast is because you've created the machine code for everything all in one go, and there it is. It doesn't have to do any on-the-fly translation, whereas with interpreted languages you have to do that translating thing like as you're running the program, right? I've already discussed the reasons why the compiled languages are less susceptible to code injection. That's because you get the executable file and you can't actually see the code, right? Yeah, stay away from energy drinks. They're just bad, man. I just got a letter. I'll have to investigate that in a minute. Disadvantages. Compiled languages will only run on the hardware and operating system it was compiled on. That is a massive disadvantage, right? If I write some code in C++ and I compile it on my Linux machine, which has a 64-bit operating system in there and a 64-bit CPU, right? It will work on the 64-bit operating system, specifically the Linux 64-bit operating system, and it will work on the 64-bit CPU, and it won't work on anything else. I won't be able to take that program and run it on a Windows machine, even if it's got the same CPU. I mean, I have Windows and Linux installed on this machine. I can't write a program, compile it on Linux, and then run it on Windows. Okay? I can't write a program, compile it on Windows, and then run it on Linux. Not directly, anyway. I can use Wine to emulate Windows, but so standalone executables. And just so that we're clear on this, an executable file is a file that you can run on Windows. They always have the extension .exe. In fact, if you've got any games installed, you can go into the folder where those games are installed, and you should find a file with .exe on the end. Any programs, if you go into your C drive, go to Program Files, just choose a directory at random, you will find an exe file. That is the file that actually contains the program. Okay, so standalone executable means here is the file that you can run. When you run this file, it will run the program. You don't need any additional things. Okay? Well, in Linux, the file extension doesn't determine the type of file, so you can call it whatever you want. I mean, no file on Linux is executable unless it has the executable flag set. And you can make text files executable files by setting the executable flag. So it's done in an entirely different way. Okay, so I got sidetracked just like answering a query there. Does it make sense what I've said about only being able to run on the hardware it's compiled on? I could write a program for this thing here. This is my Raspberry Pi. I could write a program for that. It will not work on my computer because it's got different CPU. Okay? Even though this Raspberry Pi is running effectively the same operating system, it's a different CPU. This uses an ARM CPU, not an x86 64 CPU. Therefore, I will not be able to run the code that I compile on this machine here. Does that make sense, yeah? What case is that? I don't know. It's some plastic case. My friend gave it to me. He said, "Oh, do you want a case for your Raspberry Pi?" I was like, "Yeah, all right." And he gave it to me. And that's the end of that story. It's a cool story, right? Obviously, massive downside to compilation. One error causes the whole compilation to fail, which, as I mentioned, in most situations, that's seen as a negative, right? But it can be a positive thing in the sense that that you're not going to get any sort of like half run through execution of your code. Okay? Sometimes it's good, sometimes it's bad. Mostly it's bad. Okay, and then less free. What do I mean by less free? Someone explain that to me. Less free. I mean, that's obviously the opposite to more free, which I had on the other thing. What do I mean by free here? I'm not talking about monetary cost here. What do I mean by it's less free? it's harder to freely distribute the source code. Yeah, because I mean, and also not just distribute the source code, but access the source code. If someone gives you an executable, it's like, well, there it is. It either works or it doesn't work. And if it doesn't work the way that you want it to, what are you going to do? You're going to have to write your own program, mate. Do you know what I mean? I mean, compiled languages, you can still distribute the source code, right? I mean, a lot of the programs that I run on my computer here, they are compiled. And they are open source. I download the source code from GitHub. I install I compile the code, and then I install it onto my machine. But Jenny makes the key point here. It means less freedom to be able to edit those programs if they are distributed as an executable. Okay, so the reason I put a question mark on the end there. Writing in a compiled language doesn't inherently make your code less free, right? But usually, compiled languages are used to produce standalone executables, which mean that you can't see the source code. Usually, once something has been compiled, it's then distributed without the source code. Okay, so it's not a rule that all compiled languages are closed source. But it does make it easier to hide that source code and prevent your end users from editing it. Does that make sense to everybody? Peter, whoever shared that Hunger Games thing this morning, I now have like Katniss Everdeen moaning about Peter stuck in my head, so thanks for that. Right. Are there any questions on compiled languages? Do you have any questions for me? Any things that you don't get? Any things you want me to explain? Because you know what's coming, right? It's almost the end of the lesson. I mean, it's actually past the end of the lesson, but whatever. Because the next part is this: complete the second section of the worksheet. It's just question 2. Same deal. You know, I'm only after a couple of paragraphs just explaining what compiled languages are. Feel free to reference your previous answer, the one about the interpreted languages. Yeah, and you can send that through. My A-level students, if you're still watching, if you want to get involved with this, let me know. I can share up that worksheet so that you can have a crack at answering those questions for some practice if you want. Obviously, when we cover this, we're going to have we're actually going to write some programs which will well, we're not going to write our own compiler, but we're going to write our own pseudo compiler. We're going to get pretty damn technical with that. So I'm sort of saving that until we're all back in the classroom, because it's going to be a bit of a nightmare to do over the stream. I apologise to you guys, because you might feel like you're getting a bit of a raw deal because I'm focusing more on the GCSE stuff. That's mostly because I know that we're going back soon, and really I can't do a lot of the A-level stuff from a distance. So I apologise, but keep practicing that check.io programming, because the more practice that you get there, that means the fewer lessons I'll have to dedicate to programming practice, and the more sort of theory we can catch up on when we get back there. I mean, I kind of feel bad for all of you guys, because this is not fun. It's certainly not fun for me. It can't be fun for you either. And I know that there's a lot of people who are not tuning in and they're really missing out. But a lot of that is not necessarily their own fault. It's beyond their control. So all I can say is sorry. And if there's anything, if you need anything more from me, please do get in touch so that I can help you out. If you feel that there's gaps, if there's bits that you want me to go over, then just hit me up if you feel that you could be spending your time researching something specific and you just want some guidance. Let me know what it is, and I'll help you out there. And if anyone needs help installing brackets, yeah, I haven't actually had any more emails about brackets. So there you go. But you can follow my guide on how to make a adventure game in HTML. By the way, anyone that has not yet submitted their text adventure games, I'm still looking forward to that, and I will do another stream where I play those text adventures. Okay, so you have not been forgotten about. I am going to get round to it. I will also try and give you some marking and feedback on some of the other stuff that you've done. If there's anything, what I'm going to say is, let me know, and you can pass this on to everyone that isn't here as well. If there's some work that you've done which you've handed to me and you want specifically me to give you some feedback on, please let me know so I can prioritize that. Okay, and if there's no further questions, then I will sign off. If it doesn't work and you need help getting it working, send it through to me and I will help you out. Okay? The sun is out here. I hope it's out where you are, because I tell you what, I feel really, really miserable, and a walk in the sun is usually something that cheers me up. So that's what I'm going to go and do. Suggest you guys try and do the same as well, because the world is a horrible place right now. But it can be better, and you guys can make it better. That is all I'm saying. I will see you whenever I see you next. Where's the outro? There we go.